Hello, my name is Felipe, and this is the first episode of the tutorial session of AI Soccer. And today I'm going to give a brief introduction regarding the development process of rule-based algorithms. And first of all, let's recall soccer. That's a really popular game, and everyone know the rules and know how to play, and how we improve since kids until reach professional level, such as Son Heung-min and other top players. We want to replicate that, teaching robots how to play soccer. And we have two types of robots. We have the smallest ones here, that is the junior robots, and the big ones that are the senior robots. In our game, in the AI Soccer game, we play two teams with 5 robots each, and the objective, as in soccer, is to win against your opponent. To do that, we have our AI Soccer simulator that is built in the Webots robot simulator, and that communicates with two AI programs that implement the player strategy, the gamer strategy, Team A and Team B. From the AI Soccer simulator, every time step, every 50 milliseconds, you receive the global coordinates where the robots are located and their orientation, the game state, the current score, the current time, and when the game is reset, you also receive the reset reason. This is what is communicated every time step to your AI program. And before the game starts, you also receive the game information. For example, the field dimensions and also the robot specifications. And every time step you should send back the variables that will control your robot, like the variables that move your robot and implement actions such as kick and jump. As you can see here, these are controlled by 6 continuous variables that are set in each time step. In the image you see the robot moving, jumping, and kicking. But how it is possible for the robots to move, to jump, and to kick? This is possible because inside the inner shape, the robots have 2 wheels that are responsible for moving, and we have a front slider that is responsible for kicking, and a bottom slider that is responsible for jumping. So in every time step, the action that you can do is the velocity of the left wheel, the velocity of the right wheel, the front slider height, the bottom slider, and also we have a 6th variable that is the dribble mode. If you want to check also more details on that, you can check our AI Soccer manual. But how the rule-based algorithms work? So you can think that a rule-based algorithm uses the knowledge of the gamer regarding the game, regarding soccer, to develop its strategy. So based on the current situation in the game, the gamer, with his knowledge about soccer, try to give the actions to the robots. And the rule-based scheme is usually divided in 2 parts. The first part is the strategy part, and the second is the control part. In the strategy part, you use the global coordinates of the game, like the robot's position, especially the ball position, and you choose your strategy, like the position that the robot should move, go to, and the position, and if the robot should kick or jump or pass or other kind of high-level action behavior. But just giving them this information is not enough because we need also a control part that turns this high-level action into the low-level action that the robot can understand. That is the left wheel velocity, the right wheel velocity, how the front slider should move, and how the bottom slider should move. First of all, we're going into the strategy block. What is done in the strategy block? And I will explain this using an example. So let's see the logic to get our desired behavior. In our desired behavior, we have two attackers, F1 and F2, that are in the opponent field and are trying to score. So F2 should move to the ball and rotate in order to get a successful pass to F1, while F1 is positioning itself to kick. In the second time step, F2 effectuates the pass before the defender comes to cut the ball, and the F1 rotates to get a good position to effectuate the kick after the ball comes in his direction. In the third time step, finally the ball gets to him and he has the chance to shoot to the opponent goal, and he shoots in the right side of the opponent goal post. In the time step 4, he scored after the opponent goalkeeper is not able to defend the ball. How can we implement that? So we see that actually we can define rules to implement that. The robot that passes, he first checks if the ball is in the opponent field. If the ball is in the opponent field, he can continue with his strategy. Then he checks the ball is in the lower field. If yes, he can pass the ball to the other player. If not, he should make the positioning to go until the ball to have the chance to pass. While the other robot should prepare to receive the ball. So first of all, he sees is in the ball in the opponent field. If yes, he can then check if the ball is in the lower field or not. If the ball is in the lower field, the other robot is near and will effectuate the pass. So he tried to go to the position that he should be to receive the pass. If he's not there, he should go to that position. And if he's already in the position, he just needs to turn to have a good kicking shooting direction. So if the ball arrives after the pass and they have a shoot chance, they should go to the ball position and perform the kick. Then, after we learned a little bit how we can develop strategies using the knowledge-based rules, we can go to the control block. That's the most complicated block. Before, we checked that here we say go to the position 2 in the x-axis and 0.5 in the y-axis, or kick, or go to the ball position. How can we achieve that using our robots? Our robots that use differential wheels, so we have a left and a right wheel, we should use a controller in order to go to that position and to send the actions at each time step. So how to move my robots to the target point? Using the controller, what is important is the error between my current position and orientation. It means like where the robot is right now and the point that I want to go. Here is the desired point. And I calculate the distance between my robot and this point and the error in orientation, this QE, in relation to my orientation and the orientation that I need to achieve that point. These are two variables. That's my distance error and my orientation error. The logic using this error is that if the distance to the desired position that I want to achieve, that is my target, is big, I need that my linear velocity should also be big. But if the distance is small, it means that I'm really near the point, my velocity can also be small. And if my orientation is wrong, I need to change my angular velocity and rotate until I get to the desired orientation. So using that and getting the value for these errors, I can use a controller that will define my linear velocity and my angular velocity. And from this value, I can get my right and left wheel velocity using the formulas in this slide. So my angular velocity is my right wheel minus my left wheel over my radius of my robot, and my linear velocity is my right wheel plus my left wheel divided by 2. So with this, you know the complete scheme to develop your own rule-based algorithm. You should know that we already provide the control block. So you can or refine the control changing the parameters of the controller, but if you don't know how to develop the controller, you can focus only on your strategy part, that is getting the best situation at each moment and move your robots in effective ways that you can block opponent kicks, also have kick opportunities, and have the domination of the game, keep the ball possession, and build a winning team. What are the challenges of using and developing rule-based algorithms? First is define the set of optimal rules. You can imagine that to build a strong team, you need a lot of different rules that should act together, and especially acting, using, and cooperating between robots to be effective. So it's not easy to design these optimal rules. Also, to combine the robot control and rules is a challenge. So how to effectively use your controller to implement the behavior you want with your rules. Also, it's time consuming, so it's going to demand a lot of manual work to tune what are the good rules, what are the bad rules, what are the rules that work, and the rules that did not work. And finally, there's not a rule for every situation. Soccer is a complex game, so you can imagine that there are going to be gaps in your strategy that no rule is going to be applied. So this was my first video introducing rule-based algorithms. Thank you for watching and see you in the next video.